This is problem 57 for Model 1. The driver of an automobile suddenly sees an obstacle blocking her lane. Determine the total distance the car travels between seeing the obstacle and stopping as a function of the initial velocity of the car and the magnitude of the car's acceleration while stopping. Ignore the driver's reaction time. Well, it should be easy for us to pick the events here because they said determine the total distance the car travels between seeing the obstacle. So this would be first sees obstacle and stopping, so this is reaches rest. Before I put anything in my motion information table, I want to draw the free body diagram. The driver is initially moving with an initial velocity and comes to rest, so we're going to show slowing down. And let's start at 0 and say the driver is going in the positive direction, so the initial velocity is positive. R1 is 0, T1 we'll say is equal to 0. And we want to determine the total distance the car travels, so we're looking for D. And the car reaches rest, so this is 0. And we're given the magnitude of the car's acceleration while stopping, but that acceleration is pointed in the negative direction. And so this is negative AS. Then we can draw our velocity versus time graph. And we are starting at an initial velocity of VI, going to 0. This looks just like the graph that we just saw. And I'm looking for D, so I'm looking for the area under the curve. I can start off by looking at the area and see if I can find it without finding T2. And so the area is D, that's what I'm looking for. It's a triangle, so it's 1/2 the base, which is T2, times the height, which is VI. Since there's a T2 in there and I wasn't given a value for T2, I have to get rid of this unknown. I can only have in my final answer values that they give me in the problem here. So then I look at the slope. The slope is negative AS, so the slope here is negative. The magnitude was AS. This is change in velocity, which is minus VI, so final minus initial, divided by T2. I'm looking for T2 because I want to put that in up there. So T2 is equal to, if I multiply both sides by T2 and divide both sides by negative AS, that's negative VI over negative AS, and the negative signs cancel out. Then I can take this and put it in up here. I'm going to bring this whole thing down here and say D is equal to 1/2. T2 is VI over AS times VI, and that is 1/2 VI squared over AS. And if you compare that to what we had last time, we had a negative VI squared over 2D, and if you want D, instead of the acceleration, you can multiply both sides by D, divide both sides by A, and you have what we have here, except without the negative sign. And the reason for that is here, we were looking for the cushion and we found that it was going in the negative direction. This is the magnitude here, so we already put in the sign to say it's going in the negative direction. But other than that, the functions are, you could get one function from looking at the other function. Okay, so this is my answer because everything in here I was given in the problem. It appears in my table, so I know it was given in the problem. And now I can go ahead and answer the questions at the bottom of the page. So if the driver sees the obstacle and the driver is already at a velocity of 0, then what should the distance be that it takes the driver to come to rest? That should be 0 because the driver is already at rest. If VI is 0 here, D is 0, so yes, that agrees. If the acceleration is equal to 0, which means you don't actually slow down, you just keep going at the same speed, what should D be equal to? Well, you're never going to slow down, so you would cover an infinite distance before you reach 0. Does our function agree? If a is equal to 0, we are dividing by 0, and that goes to infinity. So yes, it agrees. If the car was traveling twice as fast, how much further would the car travel before stopping? So initially we have d is equal to 1/2 vi squared over as. If the car is going twice as fast, then vi is now 2 times vi. And the new distance would be 4 times the old distance. So 2 squared is 4. And then what we have here is the same as what we had before. So this is 4 times further. And that concludes problem 57.